So what we see here is the thermal efficiency of diesel tends to be a little higher than Otto due to the fact that the compression ratio is higher. So for a typical diesel, you might have compression ratios on the order of 11.5 to 1 and 22 to 1. So you could be anywhere in that range. And given that they operate at this higher pressure ratio or compression ratio, you will then result in higher thermal efficiencies. Okay, so what we want to do now is we want to take a look at a video of a diesel cycle, and then what we'll do is we'll take a quick look at a comparison between diesel as well as Otto. So let's start by looking at the diesel cycle. So from the video and from the sound of the diesel itself, that was increasing in RPM, going up to about 2,000 RPM, you could hear that the engine itself was quite a bit louder than our Otto cycle or the spark ignition engine. And that's because, if you recall, we are undergoing compression ignition, and consequently the combustion is taking place at a higher pressure, and as a result you get more of a bang going on within the cylinder when the combustion process takes place at the higher pressure. So let's now take a listen to both of them combined, and from that you should be able to figure out that the Otto sounds a little quieter than the diesel. So the difference between the two, the diesel louder, Otto quieter, diesel more efficient, Otto less efficient. That's probably the best way to describe them. Final thing I will say about both of these, however, has to deal with the fact that our heat addition in both the Otto as well as the diesel is taking place over a finite temperature difference. And the implications of that is that is why these processes are not externally reversible. So the fact that they're not externally reversible has implications on the thermal efficiency. It lowers it. The last gas cycle that we will look at in this lecture is that of the Stirling cycle, and that is one where the heat addition is taking place over an infinitesimal temperature differential, and consequently it is modeled as being externally reversible, and it has the same efficiency as the Carnot cycle. So that will be the Stirling, and that will be the last thing that we will look at in this lecture.